And then we divide this also by permutations from 7 to select 7. So these two ingredients were calculated for you. So technically all one needed was to recall that probability is nothing else but the fraction. So in numerator, we put this 120, and in denominator 5040. So the answer will be here, and it'd be 0, 2, 3, 8, ... So most people did it just fine, and that was very good. But if you did not do the problem, and some people keep asking me, Alex, what can I do to make up for my quizzes? Every single day in class, I tell extra credit, even exercise. I don't know, some people just don't hear that. So if you want to do any even problem from chapters that we covered, and send it to me by email, all your work, just like I did here in the part B of the exercise, that's just fine. And also not attending the class meetings and keep asking me, Alex, what can I do to make up for those? Well, the answer is watch the lectures, watch the videos. You have an awesome opportunity here. Instructor records all of the lectures here. I understand some people are so extremely busy. They say, instead of watching this, 40 minutes or so of that little recording, I want to spend less time. I want to spend only 5 minutes, Alex. I don't want to spend 40 minutes and all that. It's just too much for me. So how can I do even less? Well, if you start doing the exercises that you never saw before, I don't think it's going to be saving any of your time, because you simply are not going to be able to do them. So that's why the reason is, if you missed the lecture, watch the lecture first. And then I'm sure you will be able to do very, very similar exercise to the one I did, and that'd be good enough. So it's not going to be waste of your time. It's going to be actually saving of your time, because to get to understand this just by reading the textbook will take you much longer. Believe it or not, try it. It took me a while to read all that and to start to get some ideas. But, well, maybe it works differently for you. But again, you have lectures that I send links to every day after class. So utilize this opportunity. Those links, they don't stay forever. They stay only for 30 days. 30 days, and then they disappear. So do this as soon as you can. So anyways, exercise number 7 here, that says there is a lottery game that pays off $656 million. How about that? Let me see, why did it pay so much? Well, probably because nobody can win, right? So the possible winning piles up, and there's nobody can win because there is no chance. So let us see what is going on here. So they say that the jackpot is 1 if all 5 numbers drawn will be guessed correctly. So they take out of 56 possibilities, it's an exercise number 7, out of 56 possibilities, they're trying to get 5, right? They're trying to get 5. And then they say, no, it's not enough. There is also one number, so-called mega ball, that is drawn out of 46. So we draw 2 things, and 5 and 1. Well, and means multiply. It's always like that. Right? So and means times, or means plus, and means multiply. Okay, so question is, when I play this lottery game, do they really care in which order you get this selected? What do you think? Do they really give you, let's say, 56? So that'd be 7 by 8, right? So if I put 1, 2, 3, 4, 5, 6, 7, and then 8. 1, 2, six. So you have numbers. So you selected, let's say 1, then you selected 3, then you selected 5. So the question is, do they really care in which order you select these numbers, whatever you select? You select, let's say 5. Do they really say, you know what, in which order? Was that first that you selected, or that was first that you selected? Makes no difference. Remember what we do when order is not important? We use combinations, right? Combinations. So out of 56 to select 5, and when they're not ordered, so you just select these and then put them in some pocket and you say, oh, I selected this, then okay, good. If you guessed all of them, then you're good. You're also selecting 1 out of 46, so that'd be another combinations, 46 choose 1. And looks like that's going to be my total, right? The total is right here. Total is choose out of 56, 5, and means times out of 46, choose 1. Okay, so looks like then I need to see how many are the winning jackpot winning selections and how many jackpots are there. Well, jackpot, they say 1 jackpot, right? There are not like 10 of those jackpots. So this is going to be the 1 out of that total. Right? So I need to know the total. So I'm going to calculate this number. So let me put this in my favorite calculator here. And then I will divide 1 by that total because they ask us about probability, right? So combination out of 56, I choose combinations, right? Then put 56, comma, 5, like that. And then I have to multiply this by, again, combinations from 46, choose 1. So you go back to functions, then you take this combinations again and back to numbers 46, comma 1. Just like that. So there we have it. That's the total number of selections that you can make. Look at this huge number, 175,711,000. That looks familiar. And then 536. So this is the number that I need to divide into 1. So let us do this. I divide 1 by this many million. So what is your chance going to be? What do you think? 0? No chance? Look at what I have here. You say, Alex, that's 5. No, it is not 5. That's a very, very small number. You see this power -9? So the actual number, if you decide to write it down, will move the decimal point 9 places to the left. So it's 1 place, and then there'll be 8 more. 1, 2, 3, 4, 5, 6, 7, 8. 8 more places. So there'll be 8 zeros in front of that 5. So what kind of number is that? 8 zeros. That's extremely small number. It's 5 billions. Can you imagine how small this number is? It means there is no chance. We say, no, Alex, I still have one chance out of that many million. Well, okay, go ahead, try to play it, see what happens. And probabilities, if we say the chances are 0% and some decimal, that means there is no chance. So when you take in statistics or probability class, it's good to realize that that's a 0 and something percent, that means there is no chance. Whenever it's less than 1% chance, then we say it's not going to happen. So that's standard. So it looks like the lottery games are pretty much always care about not being ordered. So they pretty much always using combinations. And that's good to realize, unless they give you a little bit extra information, because they can always create all kinds of extra ideas. So I think you selected an awesome question, and the exercise 11 is even nicer. So let's do this. So again, we're still on that same section, probabilities. I don't plan to move on from it today because I think this is a very good idea to do more and more exercises that you start to feel more and more comfortable. I don't want to rush through it, because in the next chapter, you will see word probability once again. And all one needs to realize that probability is a fraction. Denominator is the whole thing, the total, and numerator is what you're interested in. So let us get used to it, because on the previous quiz, lots of people gave me some answer like 24. So I asked you, what was the probability? Well, probability cannot be 24. Probability is a fraction. Probability is always in between 0 and 1%. So if your answer is 24, well, it's not possible. It's not a probability. Probability is always less than 1. It's maybe 1/2, like 0.5. So like 50%, 30%, so some kind of number like that. So even very, very small number, it's still less than 1. So that's important to realize. That's a first rule for probability. And that's why I think we should be doing more of these problems. So you will get used to it more and more. It's not a big deal if you didn't do 1 or 2 exercises correctly. That's fine. You can always fix it. And you know it, right? Just do even exercise of your choice. So if you like, for example, this problem 7, well, you can do 8, or you can do 10, or you can do both of them, 8 and 10, and send it to me as extra credit. So anyways, let's see. 25 transistors in the box and 6 are defective. How about that? So it looks like here we have a little split. There are some defectives, and the remaining looks like that'd be 19, right? They're good. So those are bad, and these are good. Okay, so there are some defective transistors. So the question is, you're selected at random 6 transistors. So it looks like what you do is, out of 25, you choose 6. That'd be your total, right? Total number of selections. Do you care about the order? If they tell you that all you care about if those are all defectives. Alex, I don't know. Do I order them? Well, my question to you is, did they tell you that you have to order those transistors? Did they put any information? You know, you select the 6 and then you start to order them, the one you like the most, the next and next. They didn't tell you this. That's why it doesn't matter. No order. Remember? Combinations. 25, choose 6. So in this exercise, it looks like they don't really care about order, simply because they don't tell you that you have to order. That's very important to realize. If they do care about order, they will always give you some extra story how you're going to order them in some positions or whatever, or color them or whatever you do. But they said nothing. which means that order is not important. And this is just great. So what I can do is calculate this total. It looks like this is going to be always in my denominator. So I go to the calculator and back to my favorite combinations, right? So let's put that, please, combinations. So I got combinations from 25 to choose 6. Well, this is a 177. You see that? 177 and 100. So that's our total. This will be our denominator. Okay, so what happens in the actual exercise part E? Well, they wonder, what if someone has a probability to calculate? So please notice that now we need to find probability. So that'd be a fraction. It's always less than 1. So what's the probability that we selected all 6 defectives? So out of this total, 177,100. How many ways to choose all 6 defectives? You say, well, what I want to do is just choose all 6 here. And that's the only one way. So it's just take all of them. Or one can say, Alex, I want to be consistent. I want to go with the combinations from 6 to choose 6, right? Take from all those 6, select all 6. Because they could have been 7 that you choose 6. So it doesn't really matter to us. Point of story, you select without order. And this means that you just use combinations. And of course, you will see when I put in combinations 6, choose 6, that this is indeed equal to 1, right? And I hope you see that number 1 here on the right. So it is going to be 1 divided by 177,000 something. So this is a very small chance. 1 out of some 100,000 would be very, very small. So let us write down what the answer is. So I divide 1 by 177,100. So let me clean this mess a little bit so you better see it. The power is -6. So it looks like I need to realize that I have to put 5 zeros, right, in front of this number. So it'll be 0, 0, 0, 0, 0, 5, 6, 4. Some people may wonder and ask me, Alex, do I have to write it like that? Can I just give you the answer that looks exactly like that? And I would say, yes, this is fine with me. But if you tell me that this is 5.64 or whatever, this is not going to be correct because this is really not 5.64. It's a 0.000. It's extremely small number. And that's why it's important to write the whole thing with that power of -6. If you want to do this, if you don't want to think how you convert this to decimal, yeah, that's fine with me. Just write the number that calculator gave you. Notice it doesn't take too long, maybe 1 extra second to write a few extra digits. It's not a big deal, I think, right? If you want to get a perfect result on the test, then why don't you spend extra second or 2 to write entire answer? That, I think, makes sense. So there is part B here. So they select none of the defectives. In other words, we're trying to find probability that all 6 will be good. Okay, that's very interesting how we can do that. Please notice that my denominator is always going to be total for this type of selection. But the numerator, now I'm selecting still 6 transistors, but out of only 19 good ones, right? That's what they want. So we select now out of this 19, we don't touch bad ones. We only want the good ones because, well, who knows? Maybe you're serious about doing some project. So anyways, let us see what this is. The calculator is always with us. So combinations again. And from 19, I need to select 6, right? So here it is. And I got the answer. It is 27,000. Let me get some cleaning here. So my numerator is actually 27,000. 132 that I need to divide by that number 177, 100. You don't really have to do this. You could just divide it right away. I'm trying to do it this longer way to maybe have some intuition for people that like to do this problem by hand. Some people I know like to calculate this by hand, so you can see what's going on a little bit better. So 177, 100 is still the denominator. And notice that we get another number which is less than 1 because it's a probability. It's never, ever bigger than 1. If you get the probability bigger than 1, then something went wrong. Well, let's see on the next page, do they have any more of this exercise? Problem 11, let me flip the page. And this is it. Okay, so it looks like we have 6 of those and other also like that. I can actually design a little different question, which is, I think, worth to look at it, because next page we'll do next time. I have a feeling that I probably want to go back to this page a little later. So let me design extra question, because these problems, they're far from obvious. Let me design one question that I think will be very interesting and not obvious, related to the setting of exercise number 11. Be clear with this mess. So they say, what if you select all 6 that are good? But one may say, Alex, how do you know which ones are good, which ones are bad? So you could probably get some bad ones also, right? By accident. Unless they're marked with bad, then you probably just throw them away. Why would you select? So we can find a probability that we selected one bad transistor. I say, so I just select one? No, you are selecting 6. So that's the key part. So you're not really selecting one bad. You're selecting one bad. Maybe I put it in like red. So it'd be one bad, and the rest will be good. See, they usually don't tell you the rest, but there are 6 that you select. So the rest will be 5 more, right? That are good. Again, because you're selecting 6 transistors total, and you already know there are 177,100 selections. And then from bad ones, right? Let me write this here again. So there are 6 bad, and there are 19 good. So from bad ones, you select 1, and you're also selecting 5 more, because total you have to choose is 6. So you're selecting 5 more from the good. So the way to put this in my numerator will be, out of 6 bad ones, I choose only 1, and then means times. Out of remaining good ones, and there are 19 of them, I choose 5. So this is how I'm gonna put this in my calculation. So that's worth to pay attention to. And well, then I use the calculator and get the answer. So I think it's a good idea to practice to use calculators to do functions, combinations, then go back to main 6, comma 1, parentheses, times. Again, go back to functions and select again combinations and back to main. So out of 19, we choose 5. This is my numerator, 69,000. Well, I don't really need to worry about numerator. I just divide this by 177, 100 right away and get my result. And this is 0.393, you see, 9394. Some people might say, Alex, your calculator divides only the second number. What about first number? It didn't divide the first number. Well, actually, notice when you multiply, then this first number actually goes to numerator anyways. Just the way the calculator puts it like that. So if you don't like the way it looks, if you're doubt, well, you'll always use parentheses. Did you know that? So how can I use parentheses? Well, you can go to your previous calculator, put parentheses in front here, and then go to numerator and put another parentheses in front in there. So just make sure that you have this numerator in the parentheses. Please notice it's not changing really anything, but I guess it's nice to realize it. So maybe if you don't want to do it like that, if you want to have it exactly the same way, then what you can do is the following. So you can multiply these two numbers together first and wait with dividing. So you put parentheses around the numerator and then divide this whole thing, you see, when you have numerator and the parentheses, 177, 100 in denominator. And of course, it's going to be the same exact thing. So the message is, whenever you doubt, you don't want to get a wrong result, well, put parentheses around your numerator and you will, of course, get the same exact answer. So what I just did, I made up my own little exercise and I did it. So what I can do is, just for calculation purposes, make up another exercise for you to try for a little quiz. So what's the probability that you get 2 bad ones? 2 bad. So instead of 1, you get 2 bad, which means that you actually have still 6 of these to select. So 2 bad, but you're also going to have remaining good ones, right? So that'd be 4 more that are good. And you will still put, say, 177,100 in denominator. So what be a numerator? Well, looks like there'll be 2 combinations. Out of 6, you choose 2. That's for the bad ones, right? So that's the first part. And means times. Out of how many? 19, right? 19 good ones, I choose 4. So a question to you for a quiz, calculate this. So I want you just plug this in your calculator. You don't have to do it all at once. You can do it any way you like. You can calculate numerator first and divide it. It's just for you to practice to use a calculator, not to panic when you deal with this a little bit less pleasant looking expressions. So the quiz, you just want to calculate. I already have what to calculate for you. And here's the example that I just did. And if you don't have access to this calculator, well, I can give you the access. I'm going to have this link to the calculator right now, copy and paste here in the Zoom chat and send it to everyone. So you can just click on the link I just sent. I just posted in the Zoom chat, and it'll bring you right to that same calculator that I used. So just practice. And again, the question is, what is this probability? So give me the number. And again, that should be decimal less than 1.